This is a very brief but an important relation on pseudo halides, at least from the competition point of view, because some of the questions you may find related to pseudo halides where the product of a particular reaction involving pseudo halides are asked, and for this you need to know how the pseudo halides behave in order to predict the product correctly. So we'll learn what is pseudo halide and then do maybe two questions. So we should first learn what is pseudo halides. So basically it is nitrogen containing mono-negative ions and their properties are similar to halides. Nitrogen is crossed because it's not 100% of the time that you will get nitrogen in pseudo halides, but you can say 98% or 99% of the time you will get pseudo halides. At least 100% of the time that is of our use, we will get nitrogen in pseudo halides. So how it behaves? From the name it is indicated that it behaves similar to halides, although it is not a halide. For example, we will do a comparison here and we will understand how it is similar to halide. So we have Cl minus, which is a halide, and we have Cn minus, which is a pseudo halide. So halide, basically Cl minus forms salt, for example NaCl. Similarly Cn minus, which is pseudo halide, also forms salt, that is NaCN. Similarly Cl minus form HCl, acid, and in the same way Cn minus also form acid, that is HCN. The molecular form of halide is Cl2, and similarly the molecular form of Cn minus is Cn whole twice. Now Cl minus behaves as a Lewis base because it has got lone pairs of electron. Similarly Cn minus has also got lone pair of electron, and so it also behaves as a Lewis base. So we can understand how there is similarity between the halide and pseudo halide, and we can also understand why the name pseudo halide is being given to these kind of ions. So some other examples are given here. Now let us solve few reactions so that we can understand better how a pseudo halide behaves in the same way as a halide. So in the first reaction we have the reaction between Pb plus 4 and I minus. We have learned earlier that Pb plus 4 likes to stay in a reduced state, that is Pb plus 2, and I minus is a strong reducing agent and it would like to stay in oxidation state higher than its current oxidation state, that is -1. So we have the reaction between an oxidizing agent and a reducing agent. So the final product would be such that lead would be in +2 state and I minus would be in 0 oxidation state, and hence the product would be PbI2, where Pb is in +2 oxidation state and I2 where iodine is in 0 oxidation state. Similarly the reaction will be between Pb plus 4 and Cn minus, where Pb will be in +2 oxidation state in the product and Cn will be in 0 oxidation state. So we have +2 here and Cn 0, and Cn2 is also called cyanogen. Similar would be the reaction between Pb plus 4 and SCN minus. We will have the product PbSCN whole twice and SCN whole twice, and SCN whole twice is called thiocyanogen. Now in the next part we have the reaction between Cu2 plus and I minus. Now Cu2 plus after getting reduced would be in Cu plus 1 state and I minus would be in 0 oxidation state, that is I2. So the product would be CuI, where Cu is in +1 oxidation state and I2 is in 0 oxidation state. And similar would be the reaction between Cu2 plus and Cn minus, where the product would be CuCN, such that the oxidation state of copper would be +1 and Cn would be 0. Similar would be the reaction between Cu2 plus and SCN minus, where we will have the product CuSCN and SCN whole twice. Here the oxidation state of SCN is 0 and that of copper is +1. So we see how the properties of the pseudo halides is similar to that of halide, and we will be now confidently be able to solve any questions which will involve pseudo halide in a way similar to that we solve the questions in which halogens are involved. So that was the objective of the relation. I hope I have met the objective and you have understood it better, and we'll conclude this lecture at this point of time. In next video we will deal with another important topic, that is covalent character and degree of covalency.